Good afternoon. So, going to talk about deadline servers for FIFO tasks, starvation avoidance. Just give a quick background on myself. I'm a kernel generalist developer with a specialization of finding and fixing bugs, which means that this is not my area of expertise. And I'm here to gather some feedback on some bugs that I found, and maybe they are not even bugs. So to give the background of the problem, so this is something that most of you should know about, that the chat FIFO policy tasks, they run until they sleep or high priority thread becomes runnable. But there's a mechanism where non-FIFO tasks may run when the system is full. So if we have a lot of FIFO tasks running and they're past their runtime, the configured runtime, which is usually by default 95%, like 900 milliseconds over a period of 1 second. Those other 50 milliseconds are used to run non-FIFO tasks. In that scenario, if we have like multiple FIFO tasks with the same priority, just to simplify some of the rules here is that the task that is running, it's going to continue running until it sleeps. But what may happen here is that those tasks may end up starving those other tasks that are with the same priority. If it's a CPU-bound task, it's running in user space or even kernel space under a loop. And now those tasks that are not running, they're waiting to run, they may hold or be waiting for a mutex, right? So you have two FIFO tasks running. One of those sleeps because it's waiting for a mutex. The second task starts running, taking the same CPU, takes the CPU for itself and never uses. That second task is never going to be able to pick that mutex. And it might be the case that it may even starve other tasks, non-FIFO tasks that are still waiting for that same mutex, right? And that will lead to RCU stalls and task hangs warnings on the system. So basically, you have a task waiting for a mutex. The hanging task detector notices that, hey, this task has been waiting for this mutex for 140 seconds, and now you have some warnings and stall warnings about that. So similar presentation on LPC 2021 showed a similar problem where the kernel thread was starving for a similar reason. They showed that stall-d, which is a user space solution, may be used in such cases. So basically, the stall-d, it's a fair or normal schedule user space that notices those tasks that are hanging, and then it kind of bumps their priority until the stall is resolved. But they propose a stall monitor inside the kernel that would notice such cases and bump that priority or run those tasks. But I looked it up and I even sent an email, but I never found any of the mailing list patches to try to pick up that work. So deadline servers, they were introduced as an alternative mechanism for the throttling. So instead of having a timer detecting that the FIFO tasks have run for that 1 second period of time, and now it's time to throttle and give time for the non-FIFO tasks. Now you schedule the non-FIFO tasks in a deadline run queue with the same parameters, such that it kind of takes like 5% of the CPU time. But those patches have not been merged completely yet. But it's a solution that even improves in the current situation for the fair tasks. So a proposal here that I started working on, but I thought that gathering feedback before I continue that work is using that same mechanism for the FIFO tasks. So we would pick any tasks that are not being run for a while, put those into the deadline server, and run those tasks under those same parameters. One of the challenges that I found when trying to develop that is how to pick up the next task. Maybe one of the solutions would be to put every task into that deadline run queue and let it run. And but maybe the answer is this is working as intended, right? So assigning a FIFO policy to a task is a privilege operation. So if any user has assigned the FIFO policy, it's intended that the higher priority FIFO task needs to finish, and if it never finishes, that's a bug on the system design, and not really a bug in the kernel, not something that we need to fix and care about. Or maybe we are happy that SolD can solve any misbehaving programs, or we just identify if there are any cases where a kernel thread may misbehave like that, and we fix the kernel thread and don't care about having FIFO tasks being scheduled under a deadline server. That's it.
So so SolD I think is going away as soon as we have DL server merged upstream, which maybe should happen soon. And so. Okay. And among FIFO tasks, I guess, the natural extension of the DL server is to have the hierarchical scheduler. So you schedule FIFO tasks inside deadline reservations. So currently we have RT group scheduling, and I guess the natural extension is to use essentially the DL server idea to service FIFO task. That won't solve completely your problem, because if you put more than one FIFO task at the same priority inside the same group, they will be picked up, and one of the two has a chance for starving the others. I'm not sure that's solvable in the sense that either you put them in different groups and they can be co-scheduled, but at the point you are solving already your design problem, which was you have two tasks running at a fixed priority, which always run. So that was a design problem from the start, probably.
Well, I'm wondering if there's sometimes also I was thinking use cases for real-time tasks to be in theirs, because there could be some critical real-time tasks that you want to make sure never get starved, but then let other things come in that could be run, or that if it overruns, it's not going to kill these critical ones that you run. So they're kind of almost always guaranteed to run, but you want it to run higher as a real-time task, not to basically it could. So the task could actually preempt almost everything else, and you want to give it, but you might allow some other things that can run that could possibly starve it. But maybe it's even by design to starve it. So it's like I need this thing to have be instantaneously run, so not periodic. So basically, kind of like that mixture between having a the problem I always have with deadline server is because it's best for a periodic thing, but if you have something that's event driven, but you only want it to, after it runs, and then you could throttle it after it ran so much, but it has to be able to run immediately. So that's the problem I have with deadline schedulers, is because it could always be delayed. That's,
No, that's true. But I guess if you have, so immediately, I guess, I mean, if you play with the period and deadline parameter, it's not immediate as of today, but can be quick enough for the use case.
Yeah, we tried that and we just could not find a good. It was just basically we're doing what basically I know Thomas hates, which is trial and error to get what you want. Where no, we just want something that says this will run, but if it there's cases where it starts adding too much. Kind of basically think of it as like soft IRQs, where soft IRQs will run immediately, but if you find out like we've queued up too much, now throw it off to K-soft IRQD. Yes, Chrome is. I'm not going to design, but I like to say this. What I found out was pretty much every single user space application is misdesigned, and we're the ones that are shipping them out. And now we can either fix all programmers out there. So not everyone is a kernel developer, so unfortunately. So, any other question on that?
Yeah, so I wonder if since we are already given that 5% to the fair tasks, if we give it to the other FIFO tasks, they're starving, if that's okay.
Yeah, sir.
I guess going back to what I was saying, so if you have, I guess if you have the moment you have more than one task at the same priority, what do you do? Because, I mean, one of the two will starve. Maybe you can, I guess, have deadline server for maybe your most priority thing, but then maybe you have three at the same priority and the problem is back, right? So the fact that it works for SCAD is that they'll be able to essentially be using the 5% bandwidth that we give them because they are not like fixed priority. So they will be sharing that 5% automatically. That works for normal. For FIFO, I'm not sure.
So like I said, actually right now in Chromebooks right now, I think the deadline server by itself as is has been actually good enough for now. It's like, so we haven't had a case where we need to do real time. We're just worried that we might have, there's a few things that we run unprivileged, or not unprivileged, basically running JavaScript. And running JavaScript as a real-time process is scary. And that's the thing, but the thing is these things actually have to run immediately, but if what the feed, so basically when you're playing like a game online, there are certain things that we want immediately done, but we also don't want this thing to take over the machine or lock up or whatever. So we actually said, okay, when it comes in, when we schedule it, it gets immediately, but if it starts abusing it, then it gets throttled.
But in the case, yes. If you have a group of, let's say, more than one FIFO, that we want to run a FIFO, if you put that into a deadline group, that will be running instantly, if that's the only deadline group, right? And also you will have the throttling in case they go more than what allowed. So it will still work. I guess your problem is that if you have more than one deadline thing running, then it's true that.
This is like several RT tasks, where there are several, like I said, we're not so worried about them interrupting, because a lot of times one will wake up the next, wake up the next, wake up the next. So,
yes, but if you put them in the same group.
Yeah, but that's why I said we just let them be real time and then just let the deadline server make sure that the other tasks don't. So actually I said the deadline server actually works for us right now as is. There are some cases like that it might help, but we could get by without it. So the question is do we have a strict, I guess the question comes down to what is the use case of putting, having the deadline server handle RT tasks? Because I had one case that was like it was helpful, but we found workarounds that we didn't need it. So do we want to make the code complex for something that we could find other solutions for?
No, so there is a general use case, for example, if you run in application in containers, and some of those are running in FIFO tasks, it might make sense to have group of tasks, and you can assign bandwidth to those group of tasks, and each container has its own RT bandwidth, and that is actually use case. It's different from this one. It is a use case, so that's probably what we're gonna do.
Or actually, if we could actually make the deadline server replace RT groups, Yeah, that's the idea. That's the idea. That basically, because that's the thing is right now RT groups are just broken. In fact, everyone that enables it, and then they get a bug report saying like internally is like we just said turn it off. That's basically the solution for RT. Kind of like the same solution for SE Linux.
So, question?
Yeah, so in our case, we are using SCED-RR, but as Euro was mentioning, if it's SCED FIFO, putting it in a DL server would not help because...
No, not SCED, yeah. I said SCED-other is DL server, yes.
Yeah, but in his use case that he was mentioning, putting the SCED FIFO in a single DL server group will not help because that will keep on running, right? So either you have to put individual task into a group, but we don't know which task to put, so I don't think DL server would work for this scenario. Probably Stoldi would be the better option.
I had one scenario where I said, oh, this would help, but then we found something else, and this is, yeah. So that's why it's like it didn't really need it. Anyone else?
So I think like the deadline server between RT tasks would not make sense in a pure point of view, except for the RT group when you explicitly specify you want to give up. But like as a general, I think that will just break the whole concept of like that designing priority and stuff.
There's no compose. If you've got two different FIFO users, you can't smash them together and hope that the result is anywhere near the same. So you have to then isolate them between each other. And the only way to do that is with FIFO, with the deadline service.
So wait, how do you repeat that so people online can know?
Very near miss. So the problem is that SCED FIFO fundamentally does not compose. If you have two separate FIFO workloads and you smash them together, it'll be a train wreck. It will just not work. So the only way to do that is to isolate them from one another, and the only way to sanely do that is with deadline service. The thing that FIFO C groups currently does is horrific and broken. It sort of does this, but it's, yeah. Everyone wants to. There's just a small matter of affinities.
Anyone else?
Okay.
So what you are saying that you want different applications to have their own RT priorities defined independent of other applications, and you assign bandwidth to them with the deadline servers just basically, so you give like 50% like kind of fair to each application, and the RT priorities hierarchy work locally only for that application kind of. Okay.
Did you need a response or no? We have like 3 minutes, so anyone else? Otherwise we could just go on to the next.
Okay.
Thank you.